Hello everyone, this is Priya. I am from BSc Chemistry Honors 6th semester and today I am preparing a video for visually impaired students and my topic is water pollution. Water in abundant amounts is required for use in agriculture, industry and household. After use, however, it gets highly polluted. The various water pollutants can be classified into as many as 10 categories. These are discussed below in some details. Various water pollutants. Number 1. Sewage and other oxygen demanding wastes. Sewage from municipalities and other oxygen demanding wastes from industry and agriculture comprise of organic matter which undergoes oxidation readily under the action of microorganisms. These wastes are generally disposed of by dumping them into nearby rivers. If the amount of sewage or other waste discharged is relatively small, the dissolved oxygen is sufficient to convert carbon into carbon dioxide, sulfur into sulfates, phosphorus into phosphate, and nitrogen into ammonia and nitrates, and the river water is not so badly polluted. If, however, the amount of discharge is heavy and the dissolved oxygen becomes insufficient, carbon is converted to methane and nitrogen compounds are converted to amines which give offensive odor of rotten fish decaying in a cesspool. The sulfur compounds change into hydrogen sulfide which gives smell like that of rotten eggs, and phosphorus compound produced give a wormy odor. Thus, sewage and other oxygen demanding wastes become water pollutants on two accounts. Number one, they give rise to compounds which have an extremely annoying odor. Number two, they deplete the dissolved oxygen from water, which is rendered harmful because water devoid of dissolved oxygen cannot sustain aquatic life. It affects or even kills fish and other aquatic living beings. Number two, infectious agents. Sewage from municipalities is almost invariable associated with disease microorganisms. This is due to the fact that in a fair sized community, a few inhabitants at any given time must be suffering from disease such as dysentery, typhoid, cholera, etc. The faces and urine of such patients would contain disease microorganisms which are transmitted through water supplies. Thus, waste water from municipalities would almost invariably carry agents, bacteria, or other microorganisms which produce disease in other living beings, men and animals, including livestock. Number 3. Plant nutrients. The presence of plant nutrients is in lakes and slowly moving water introduced through runoff from farmlands, sewage treatment discharges, and from fertilizer factories supports high population of aquatic plants which on decay produce disagreeable odor. Not only this, these plants also deplete dissolved oxygen, making the survival of aquatic life, fish, etc. problematic. The enrichment of water by nutrients is known as eutrophication. Lakes and slow moving waters age through eutrophication, and over periods of several millennia they get converted into swamps and marshes. Eutrophication has an adverse effect on fish as well. The aquatic plants which bloom in lakes sink in autumn and winter and decay the next summer, depleting oxygen from the lower, colder parts of the lake. The cold water fish, which according to Darwin's theory get habituated to require more oxygen, cold water dissolve more oxygen for their growth, have to face shortage of dissolved oxygen. As a result, the cold water fish lose out of warm water fish which need less oxygen. Humans who prefer cold water fish are thus deprived of getting their choice fish. Number 4. Exotic organic chemicals. The exotic organic chemicals includes pesticides, surfactants, among us detergents, many industrial products, and several decomposition products of other organic compounds. Analysis of polluted water reveal the presence of a wide cross section of these compounds as also many others. These organic chemicals are generally toxic to fish. Some of these are toxic even at extremely low concentration around 1 ppm. With the fast development of chemical industry, several new organic chemical compounds are introduced every year which may find their way into rivers and lakes. Since the effect of these new compounds on natural ecosystem may not be known, there is every possibility that an irreversible damage is done before scientists realize it. Number 5. Inorganic minerals and chemical compounds. A large variety of inorganic chemicals find their way into normal water from municipal and industrial wastes, water and urban runoff. These pollutants, comprising of compounds of HGP, BASCD, NaCAF, etc., injure or kill fish and other aquatic life and also render the water unit for drinking or for industrial use. A prominent example is the presence of mercury in water. At one time, it was believed that metallic mercury sinks into the sediments and remains there in chemically inert metallic form. But now it is known that anaerobic bacteria in bottom muds convert inorganic mercury into methyl mercury CH3Hg positive, which can lead to mercury poisoning in living beings. In petroleum drilling, brine is discharged along with crude oil when the latter is pumped to the surface. Sometimes the volume of brine may be more than 3 times the volume of crude oil recovered. This brine is potential pollutant for water. Minerals containing sulfur, example iron pyrites, copper pyrites, on coming in contact with air and water yield sulfuric acid, which is carried into lakes and rivers by water draining from the mines. The presence of the acid affects aquatic life. In cold countries, NaCl and CaCl2 are added in large amount to melt snow from the roads in water. This salt eventually run off the roads and contaminate well water and also find their way into lakes and rivers and seriously affect the aquatic life. Some other metals whose compounds frequently act as water pollutants are lead, arsenic, and cadmium. Lead. Compounds of lead which enter into water are PbCl2, PbBr2, PbBrCl, PbO, PbS, which originate from lead minerals. Lead in the form of PbOH whole twice gets its entry into water from lead pipes. Excessive intake of lead by humans causes disruption of synthesis of hemoglobin. It also results in loss of appetite, anemia, kidney malfunctioning, nervous disorder, and brain damage. Arsenic. The main source of arsenic compounds in water are pesticides, fungicides, and herbicides. Arsenic contamination may also occur due to discharge of some industrial waste. Dissolution of arsenic mineral is another source of arsenic compounds. Arsenic 3 compounds are highly toxic. The toxicity arises from the complexation of arsenic 3 with SH groups of enzymes, which leads to inhibition of enzymatic action in human body. Since arsenic is structurally similar to phosphorus, its presence interferes with the process of phosphorylation in human body. Higher doses of arsenic result in coagulation of protein, which causes cramps, paralysis, and even death. Cadmium. Cadmium finds its way into water from industrial discharge and from nickel cadmium batteries. It is highly toxic. Excessive dose cause kidney malfunctioning, anemia, disorder of bone marrow, etc. It may be mentioned that according to the International Register of Potentially Toxic Chemicals of United Nations Environment Program, there are nearly 5 million known chemicals in the world today, and today 40,000 new chemicals are added to this list every year. Of this, about 75,000 chemicals are in human use among us, which is large number are positively known to be toxic. A brief list of toxic elements whose toxic ions are most commonly present in municipal and industrial water is given in table 2 along with their sources and adverse effects. Arsenic sources: pesticides, chemical waste, mining byproduct. Adverse effect: enzyme inhibitor. Beryllium sources: nuclear power and space industries. Coal. Adverse effect: toxic, carcinogenic. Boron sources: industrial waste, detergents, formulation. Coal. Adverse effect: toxic to some plants. Cadmium industrial discharge, metal plating, nickel cadmium battery, mining waste are its sources, and its adverse effects are causes high blood pressure, kidney malfunctioning, anemia, disorder of bone marrow. Chromium. Its sources are metal plating industries, and adverse effects are chromium 6 is carcinogenic. Copper. Its sources are metal plating industries, mining, mineral leaching, and adverse effects are not every toxic to animals, toxic to plants and algae. Hence, these are some examples of toxic ions which are most commonly present in municipal and industrial water in given table 2. As is well known, the normal growth and development of animals and human beings are brought about by specific enzymes present in their bodies. The toxic ions in general attack the active sites of these enzymes, react with the SH group of the enzymes, and thus cause their complete inactivation. As for example, enzyme plus Hg2 positive gives the blockage of the active sites of the enzymes plus 2H positive. The functioning of metalloenzymes is inhibited by the replacement of the harmless metal ions of the enzyme by the toxic metal ions. It is to be noted pertinently that it is not the presence of particular chemical but its concentration which actually matters in chemical toxicology. Those elements such as AS, AL, SB, BA, BE, CD, CO, CU, CE, PB, MO, HG, ZN, etc., which are listed as environmental hazards, act as nutrients in trace concentration and are essential for normal growth and development of animals and human beings. Arsenic trioxide, a deadly poison, is known to act as a tonic at trace concentrations. This means that the pollution control we have only to control the concentration of the toxic elements. Any number of toxic elements may be present in drinking water, but as long as their concentration are below the prescribed limits, they are harmless. The permissible limits for some common elements, as laid down by the United States Public Health drinking water standards, are given in Table 3. The BIS Bureau of Indian Standard values wherever available are also included in the table. The drinking water pH should be colorless and odorless. Its pH should be lie between 6 and 9. It should be free from harmful microorganisms and its dissolved oxygen content should lie between 4 and 6 ppm. It should not contain the aforementioned chemicals beyond their permissible limits of concentration. Number 6. Sediments. Sediments are particles of soil and mineral which are washed from croplands, undeveloped lands, unprotected forests, soils, overgrazed pastures, strip mines, roads, bulldozed urban areas, etc., by storms and flood waters. Sediments fill reservoirs and stream channels, plug water filters, erode power turbines and pumping equipment, and reduce the amount of sunlight available to green aquatic plants. The sediments also cover the fish nets, the eggs laid by them in water, and their food supplies. This reduces the population of fish and shellfish. Number 7. Radioactive substances. Radioactive substances from nuclear power plants, waste of uranium and thorium mining and refining, and from industries and institutions, medical and scientific, which utilize radioactive materials, if carried by water, become sources of harmful radiations. Number 8. Heat. Large amounts of water are used for cooling purposes in thermal and nuclear power plants. Water is also used as a coolant in some industries. Cooling water is thus discharged as a raised temperature. The increased temperature has several adverse effects on certain properties of water. The rates at which chemical reaction occurs increase considerably. This results in faster assimilation of water waste and hence faster depletion of dissolved oxygen, which affects aquatic life. The rate of evaporation also increases appreciably with increase in temperature. This results in greater wastage of water in the forms of its vapor and so on. Number 9. Oil. Oil pollution results from discharge of oil from oil tankers and offshore drilling rigs accidentally or initially. An example of accidental oil discharge was the release of about 1 lakh metric tons of Kuwaiti oil on March 18, 1967, when the ship ran aground off Cornwall near England and broke into 3 pieces. The Royal Air Force spent several days trying to set the oil afire with high explosives. Even now, several large tanker accidents are occurring every year. The most serious environmental hazard is
Living history was caused by the spilling and burning of tremendous quantities of oil emanating from Kuwaiti oil wells, which were blasted off in the Gulf War by the Iraqi troops, and they were forced to retreat. The awfully hazardous pollution which was caused to the surrounding atmosphere and adjoining oceans was unprecedented. Enormous damage was done to aquatic life. Oil is also discharged from oil tankers intentionally. A tanker carrying a cargo of crude oil, after discharging the oil at the seaport, fills up its tanks with seawater to act as blasts on the return trip. Before the tanker docks, the seawater blast, contaminated with the small residue of oil left in the tank, is returned to the ocean. Some vessels which use oil fuel also tend to produce oil slicks, which, when waste oil or seawater blast is dumped into the ocean from their fuel tanks. The most adverse effect of oil pollution is on the seabirds. The oil penetrates their feathers, displacing the air, which is normal, trapping in the feathers and provides buoyancy and insulation against cold. The elimination of entrapped air makes the birds colder and more susceptible to disease. In the absence of entrapped air, the birds experience difficulty in flying. For instance, about 1 lakh birds lost their lives when the Kuwaiti oil tanker met with an accident on March 18, 1967. Oil pollution adversely affects the other ocean life as well. Some of the constituents of oil, such as 3,4-benzoprene, are carcinogenic. Number 10, detergents. Detergents comprise of surfactants, example surface active agents, which are organic compounds having polar or hydrophilic groups such as COOH, SO3H, NH4 positive, or non-polar groups soluble in water. Some common detergents are given below: linear alkyl sulfonate, alkyl benzene sulfonates, quaternary ammonium salt, polyoxylethene, nonyl phenol, where R1, R2, R3 are straight hydrocarbon chains, R4 is an aromatic chain, X is a halogen or an acid group, M is a cation such as Na positive. The surfactants in detergents cause a variety of pollution problems, some of which are as follows. Number 1, surfactants are highly resistant to the action of biological agents and thus do not undergo biodegradation. Since the surfactants tend to retain their identity, their elimination from municipal waste waters by the usual treatment becomes problematic. Number 2, surfactants tend to inhibit oxidation of organic substances present in waste waters by forming a sort of an envelope around them, with the result that these substances do not undergo oxidative degradation during the treatment of wastewater. Their substance generally being toxic cause water pollution to which there is no remedy. Number 3, being surface active, the surfactants cover the surfaces of small particles in colloidal suspension, thereby stabilizing them considerably. These colloidal particles do not aggregate and hence cannot be easily filtered off during subsequent treatment. The stabilized colloidal particles also reduce the activity of biological filter beds and activated sludge. Number 4, the most undesirable effect of surfactants is their tendency to produce stable foam in rivers, sometimes several meters high, especially as at low gates. These foam extend over several hundred meters of the river water. The builders used in the preparation of detergents mostly consist of sodium phosphate, which forms stable soluble complexes and hardness liberating ions such as Ca2 positive and Mg2 positive. These complexes act as plant nutrients and support rich growth of aquatic plants, which deplete dissolved oxygen when alive and produce disagreeable smell on decay. In the view of the above problem, research is now going on to discover surfactants which are biodegradable and builders which are non-phosphatic. Treatment of domestic wastewater. The composition of municipal sewage depends largely on the wealth and habits of municipal population and the amount of nature of industrial waste waters added to the domestic sewage. Sewage treatment processes are designed to remove oxygen demanding organic waste, suspended and dissolved solids and bacteria. The treatment process are generally divided into three categories, which are primary treatment process, secondary treatment process, tertiary treatment process. These are described below in some details. Number 1, primary treatment process. Primary treatment processes involve removal of grit, screening, grading, flocculation, sedimentation, and skimming. Systems of grit removal and screening are designed to remove the large suspended or floating materials such as rags, paper, twigs, wires, roots, glass and other matter. The material removed by screening the incinerated or buried. Flocculation is carried out by agitating wastewater by mechanical stirres or air injection. This causes small suspended solids to collide and form bigger aggregates which settle down more rapidly. Sedimentation, that is removal of suspended solids by gravitational settling, is carried out in large basin having a continuous flow with detention time of 4-6 hours. Specific wastes from industrial sources are subjected to removal of oil or grease in skimming tank, neutralization of excessive alkalinity or acidity, and precipitation or ion exchange treatment or heavy metals. Number two, secondary treatment processes. Secondary treatment processes include the use of biological methods employing trickling filters and activated sludge plants. The use of both the techniques is described below. Use of trickling filters. Trickling filters comprise of beds of crushed stone embedded with biological slimes. Wastewater is allowed to percolate through these beds. When the organic matter present in wastewater gets absorbed or slime and undergoes decomposition by bacteria and fungi present in the slimes. When the slime layers become very thick, their slope often can be easily removed. Activated sludge process. This process involves continuous circulation of biological active growths through wastewater in the presence of oxygen supplied as fine bubbles of compressed air. The suspended and dissolved organic waste, well aerated and mixed, undergo adsorption, flocculation, oxidation, and biological degradation. Other sludge handling methods are dewatering on sand belts, vacuum filtration, and centrifuging. Dewatering on sand belts is carried out by filtering water through sand beds and evaporating water from the sludge surface. In vacuum filtration, a horizontal drum covered with suitable filter media is partially submerged in wet sludge. Centrifuging is generally applied for dewatering paper mills, waste packing house waste, foundry sludge, water softening, and refinery sludges. Number three, tertiary treatment process. Advanced wastewater treatment process. These processes aim at improving the wastewater quality to the point at which it can be refused. The increasing cost of water supplies and the increasing emphasis on wastewater quality are leading engineers to devise methods for total recycling of decontaminated water. Some common advanced wastewater treatment processes are discussed below. Chemical coagulation and filtration. In this process, the wastewater is treated with chemical coagulants such as alum, ferric sulfate, ferric chloride, etc., as a result of which the suspended matter gets coagulated to form flakes. Carbon adsorption. The wastewater is treated with activated carbon, which is a porous and highly absorbent form of carbon with a large surface area. This treatment, because of adsorption, eliminates material responsible for undesirable taste and odor. Chemical oxidation, ion exchange, electrolysis, reverse osmosis. These are some above discussed processes. Industrial wastewater, its contamination and treatment. Industrial wastewater is invariably contaminated. The nature of contaminants depending upon industries from which the water is obtained. These aspects are discussed below briefly. Wastewater from food processing industry and wastewater from textile industry, wastewater from paper and pulp industry, wastewater from chemical industry, wastewater from petroleum industry and from metal industry, wastewater from other industries. Treatment of industrial wastewater. It is evident from the above discussion that if industrial wastewater is discharged into lakes, rivers, or ocean, as a result it would cause several pollution. This wastewater thus has to be treated properly before it can be disposed of. Since large amount of waters are required by many large industries, there is great emphasis on subjecting industrial wasters to advanced treatment, which tertiary treatment do render the water suitable for reuse. These treatments are essentially the same as carried out in case of municipal wastewater. Thank you.